All right. Thanks, everyone, for joining us for this next talk. Pretty cool one, especially if you're interested in alternative languages for writing your smart contracts. It is Zigitrum, fast and simple smart contracts in Zig, and it's going to be presented to us by Chris, who's an integrations engineer at Offchain Labs. So let's give it up for Chris, everyone.
Thank you. Thank you. Thank you. All right, so my name is Chris, by the way. That's my socials, Chrisco512. I'm an integration engineer at Offchain Labs, and I'm here to just explain to you how to write contracts that target Arbitrum in Zig. And what is Zig? Zig is like a newer language. It was created in 2016, which is, for programming languages, it takes a while to get maturity, and so it's still considered a young language, but it's quite robust 9 years in. But it is a general purpose language, but it is suitable for smart contract dev because it focuses on simplicity, explicitness, and no hidden control flow, which is really good in smart contracts because a lot of times you're really concerned with security and how your state flows and which state changes you're making and making sure that everything's like predictable and testable. So these are the things like Zig is really good for. Oh, and that's the Ziguana. That's the official logo there. So the main goals of Zig is to sort of like be, it's sometimes called like a replacement for C, but its goal is to be like a simpler, safer, more maintainable C. So it's supposed to be more accessible and easier for beginners to learn, and it provides a lot of utilities that make it easier to use than like C or C++. At the same time, it has like seamless interop with C and C++ because it has like a built-in C compiler into the Zig compiler, so you can easily like import C libraries and incorporate them, like cryptography libraries that have been around for 10, 15, 20 years in C, and pull them in very easily, and you could just pull the source code in and compile with the Zig compiler. It also has fine-grained control over memory and performance, and that can be useful in some smart contract contexts. But basically, like, unlike, say, Rust, where the memory is sort of managed for you, this does allow you to control the memory more so, but at the same time, it provides easier abstractions than C and C++ do for doing that. So this is like just a basic hello world. As you can see, it's like really simple. It's C-like. You got a public function main, returns a void. It's assigning a string. It's using the debug print to print hello world. Pretty straightforward. So yeah, again, to kind of go over some of the architecture benefits is like one of the things that it has is no hidden allocations. Memory management is explicit. So you do use allocators to allocate memory, but there's some cool, just simple abstractions for working with it that makes it less intimidating than like using malloc and C or whatever you might use in other languages to do so. It also has this concept of comp time for metaprogramming, which is really nice because you're just programming in Zig, and at compile time, it will evaluate that expression and then sort of inline the result of that expression into your code. So it's sort of easier to work with than macros, and it's a powerful concept for doing metaprogramming, which can be useful in smart contracts because a lot of times it helps to do things at comp time if you can inline something and void the binary below it or whatever it might be. So it's a very useful primitive, and I use it in the framework that I'll go over in a minute. Yeah, it's a procedural-like syntax. It's got built-in compilation, cross-compile from your machine to any target. You can compile from ARM to x86, x86 to ARM. WASM is a first-class target as well, which makes it suitable for Arbitrum's Stylus WASM VM. And as I mentioned, the C and C++ compiler is built in, so you can easily integrate C libraries in your code. Again, reiterating, there's no hidden control flow. Typecasting is explicit. There's only safe and unambiguous type conversion allowed. The compiler will catch anything that's unsafe. As far as casting goes. There's no operator overloading. You can't overload the plus sign to do something arbitrary. That's just going to do regular integer addition. There's no way to overload that behavior. So that's kind of nice because you're avoiding like unintended side effects, which again in smart contracts you don't want unintended side effects anytime. Yeah, so kind of I think it's like, this is sort of the pitch of Zig. It's simpler to learn than Rust. So Rust is great, it's memory safe, it's a beautiful language. But it does have some complexities with dealing with the borrow checker and dealing with lifetimes. Some of the generics are a little hard to grok for beginner programmers. So it's simpler than Zig, but it's as fast as C. Simpler than Rust, but as fast as C. So easier learning curve. This is just going over like some of the features of like how to integrate C or C++ libraries in your code. But I'm gonna skip over this part real quick. Again, like even though Zig is not as safe as Rust, it does have a lot of memory safety features built in, and it gives you more guardrails than C or C++ does. There's no garbage collector, so the memory is managed with explicit allocation. And a lot of times Zig libraries are functions such that you can pass in your own allocator. You can bring your own allocator for your custom use case. And as long as it matches a certain API, then it'll work just fine. You just drop in allocators. Like the debug allocator, for example, when you're running tests, a lot of times that's what you're going to pass in to your functions, and it will catch use after free or double free errors. However, when you finally compile your code, you can strip out those checks there, so that there's no runtime checks in your code to like make your binary real small and more performant. So yeah, the safety checks can be stripped out very easily, but you can still catch them in testing with that test allocator. It's less strict than Rust. You're not gonna, Rust is very strict about memory safety, but it's sort of like a middle ground between C and Rust, which it might be a sweet spot for some people. So that's one of the interesting things about it. So Zig is growing very fast. It's a relatively young language, but it's got exponential growth. A lot of people are picking up on it because it's again like a simpler C. It gives you more performance than a Go or Java would give you, but maybe easier to pick up than Rust for some devs. These are some of the products that are currently built with Zig. The most popular one might be Bun, which is a very popular JS and TypeScript runtime. That's all written in Bun and Zig and has been around for a few years. Tiger Beetle, which is a very high-performance financial transaction database, and Ghosty, which is a very good terminal emulator. So why Zig for smart contracts? Why is it a good language for smart contract dev? Well, it's a simple procedural language. So the control flow is very predictable. It's easy to follow. The high performance is there, and it produces very compact binary sizes, which remember on like Ethereum-based blockchains, we've got a limit of 24 kilobytes for how big a smart contract can be. And that's not a lot of space in the modern era. And sometimes compilers take that for granted, and they don't with certain languages they can produce large binaries, and that can be a problem for this limited environment that we have in the blockchain space. So it's also a very fast compiler, so it compiles in sub-second speeds. It's very, very good. So it's easy to work with. It also has out-of-the-box support for arbitrary precision integers, which is fantastic, up to 65,000 bits, which is huge. But Solidity works with 256-bit integers, which is weird for a lot of languages. A lot of languages only support up to 64 bits, maybe 128 bits, but Zig supports 65,000 bits out of the box. So you got that arbitrary math on large integers, no problem, and there's no external libraries needed to support that. So that's a really nice feature of the language that supports such huge numbers. It's got cryptography built into the standard library, very useful like SHA-3 and Ketchak 256, which is useful, of course, for matching Solidity ABI specs, which uses Ketchak a lot. So the idea behind this framework that I'm going to show you, which is just sort of like an early stage demo of a Zig framework for Arbitrum Stylus, is that it has zero dependencies. It just runs on the standard library. It's using a router-based architecture, almost like maybe like a web server, like an Express.js or something like that. And it supports middleware, so you can just drop in middleware to run before your routes. And that's useful for things like auth or checking ownership and things like that in front of your handlers. Also, the goal is to like make it super easy and learnable and make it very testable. So trying to stick with mostly functions, composing other functions to make everything like really testable and predictable. Okay, so let's go to the code. I'm going to exit and go to my terminal. And let me zoom in, and we're going to open Vim. Okay, oh, yeah, I'm going to go to the example. I'm just going to cut right to the counter demo. So I'm going to demonstrate how to work with the counter. So this is kind of the framework. And is it big enough? Let's see. Let's zoom in more here. Okay. Yeah. So we just import the Wax library, and we set up a context which is going to contain all the VM variables, including like block number, message sender, all of these things that are just sort of global variables in Solidity. They're just going to be attached to this context object. So that's what we're setting up here. We're also setting up a router, and we're passing in the data struct, which is going to describe like the layout of our data on our smart contract. So we've got a simple count with a 256-bit integer, and we're wiring up two routes, count and increment. And right here, like these are three parameters. This is basically describing the text name of the route. That can be anything arbitrary to like match the Solidity API selector spec. And then you can pass in middleware here in the middle, which I'll show in a minute. But for now, let's just show the quick demo with count and increment. And then here's the function definitions right here. This is just a basic increment. It receives a pointer to the context, and then it's grabbing from the store on the context. The store gets attached to it, and then you use basic getters to get the value. Then you set it to increment that value. And then this is a basic getter to get the count. This little exclamation point is just like an error union. So it's just saying that an error could be returned from this function. Yeah, so that's just how you set up your return data. And then this is just sort of boilerplate. This is the user entry point. This is where Stylus's VM actually calls into to execute the contract, and it passes in a link. So this is just sort of like boilerplate that you would copy paste into any contract you'd build. But notice how it is basically, we call this dinit on the context right here with this defer keyword. That's how Zig manages memory freeing. So you call defer, and basically that's going to run at the end of the block. So it's like memory is being allocated whenever you're calling context.init, and you're going to defer to the end of the block that it's going to call dinit to free that memory at the end of the block. So that's just how Zig makes it easier than just remembering to do malloc and manage that. That defer keyword is really handy for that. And then we're just passing in the routes in the context of the router. And then to demonstrate this, we're going to go ahead and let's cd into that examples counter folder. We're going to Zig build it. And then we're going to cd to the Zig out bin, and that's got a little main.wasm file in it. And right now I've got like the Arbitrum Stylus dev node running in my local machine, which we have a link to on our docs, like an Arbitrum docs.arbitrum.io. You can learn how to set up Arbitrum Nitro dev node to run smart contracts on your local machine that support Stylus. It's very simple to get going as long as you have Docker. And then, so we're going to go ahead and deploy that we're going to use Cargo Stylus. So this is a Rust utility that you will need to download in order to deploy. But it's going to, I've got this all filled out already with my local variables for my local endpoint private key. It sets up a private key whenever you run the local Nitro node that you can just use it. It funds it with like thousands of ETH, and you can just use it to deploy contracts locally. But that's all on our docs.arbitrum.io if you got any questions about that. But we're just going to pass in this WASM file. This is the same tool you use to deploy Rust contracts on Stylus, but you can also deploy any arbitrary WASM. And so we're just passing in that main.wasm there, and it's going to run, and it's going to give us a couple of data points. So the contract came out to 1.4 kilobytes compressed. And this is the contract address. So if we want to call it, I'm going to set a quick local variable here. And then I'm going to use Foundry's cast tool to just kind of invoke increment here. And that incremented the counter. And I think if I just call cast call, it should return 1. If I call it increment again, call again, it's 2. Okay, so the counter's working perfect. It deployed fine. It was nice and compact and really sort of simple and straightforward to do. Okay, so let's go over just a slightly more advanced use case. We've got 4 minutes to go, but just kind of show sort of the direction the framework's taken with this middleware pattern is this is just a modified example of what we just saw, where it's still a counter, but it's an ownable counter. So now it has an owner address, and it's got this claim ownership function, which we're just using to the contract's going to be initialized with an owner of 0 address. And then the first person to call claim ownership, this is not how you would do it in production, but just for this basic demo, we're going to just allow anybody to claim it, but it's running on our local, so it doesn't really matter. And then once calling claim ownership will basically make you owner. And then we're going to guard this increment function with this only owner middleware. And the only owner middleware just looks like this. It gets a context pointer and a next function pointer. And the next function pointer is what you use to invoke the next function in the chain. You can chain any number of middleware together. And it's just checking the current sender versus the current owner. And then it reverts if it's not the right owner. And then this is the claim ownership. It'll revert if it's already been claimed, but otherwise it just lets you claim ownership of the contract. Okay, so with that in mind, we're going to go ahead and build this one. Let's CD out into this example. And I think we're back here, CD into counter owner. And then we're going to zig build this. And then we're going to CD zig out bin. Cargo Stylus, Stylus deploy main.wasm. Okay, this one's a little bigger, 2.3 kilobytes. So it's got those extra functions and utilities included. And we're going to go ahead and set this variable up here. And then we're going to cast call, or we're going to try to cast actually, the count's currently 0. And then if we cast send, increment, it should revert because it only allows the owner to call that. So if we call the owner function real quick, which we should expect an address back, and the owner is just a quick getter. And right now the 0 address owns it. So we're going to go ahead and call the claim ownership function to claim ownership of the contract. And now if we call owner, that's the demo account that Arbitrum Nitro sets up for you. And then now we should be able to call the increment function, right? So we should just be able to increment the counter now and get through that middleware check. And that looked like it went through. And if we call the count now, expecting a uint 256 back, we should be able to get that count. And there we go. So now we're able to just arbitrarily call increment as the owner and get that. So we got a working demo with very simple middleware pattern that sort of maybe takes the place of modifiers and Solidity, but it gives you a little bit more control over the flow because you control when the next function is called, and you can even arbitrarily define this in the middle of your middleware, and it'll bubble back up when the handler is completed. So very cool, interesting, maybe new language to try on Arbitrum. And there's a lot of excitement about Zig, so I hope you can try it out. There is, if you want to scan this QR code, you can check out the repo. It's currently in my personal repo, but we'll probably have it on Offchain Labs soon. And there's also a link to docs.arbitrum.io where you can get even more details about the full Arbitrum stack. And we do have a Telegram Stylus group, which is a lot of cool hackers in there that are working on both, Rust and various languages for Arbitrum Stylus. So it's like just at t.me/Arbitrum_Stylus. Check that out, and appreciate your time. Thanks for coming out.